Hi, my name is Murthy Upmaka. I'm a field solutions engineer for Keysight Technologies. This is the second video in the series of some fundamental settings in SystemVue that will help you realize more advanced architectures for the phased arrays. In the first video, I discussed the custom mapping of the element patterns and S parameter file so that we can get a very accurate array antenna model. Once we get an accurate array antenna model, the next step is to go for interesting and advanced use of that array. One of the uses of array, one of the interesting uses of the array is to produce multiple beams. In this video, we will see how we can produce multiple beams. As we all know, SystemVue has two environments. One is the frequency domain, the other one is the time domain. In the frequency domain, we call it as phased array analysis uh, for designing phased arrays. In the time domain, we call it beamforming. So in the frequency domain, we cannot input multiple angles into the phase shifter and ask the simulator to produce multiple beams. So how are we going to produce the multiple beams in the frequency domain? We first start with the time domain. In the time domain, we start with a component called beamformer weights, the leftmost part here. What it does is if you input multiple pairs of theta and phi, it will compute the beam weights for all those pairs. In this particular case, we have taken the 19 beams as desired by the 3GPP NTN standard, and we input the angles for all the 19 beams. It is producing at the double green arrow the 19 sets of beam weights. Now the size of these beam weights depend on the array. In this case, we have a 38 by 38 size of the array. So it is going to produce a matrix of beam weights for each angle, 19 of them. Then we have to propagate all those 19 sets to the adder. The way we propagate them is by defining a bus wire. As you can see the notation, W is an arbitrary name. W of 1 colon 19 will have 19 wires, each wire propagating one set of the beam weights. All of them then come into the adder. They get added up. All the 19 matrices are added to produce one output matrix, and that comes into the sink. The sink called 1, 2, 3 here. We also have the rest of the portion of the schematic is to verify whether we were producing 19 beams in the time domain itself. So once we capture the beam weights, we are going to bring them into phased array analysis schematic in frequency domain. The way we do that is we use this syntax to extract W beams, and then we reshape the beam, W beams, as a row by columns matrix. Then we bring those angles of the W beams and assign them to the phase shifter. We bring the amplitude and assign them to the attenuator. The phase shifter and attenuator together will then produce the 19 beams as shown on the right hand side. So this is how we can create multiple beams in phased array analysis. Thank you very much for watching this video.